Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. In this video, we are going to continue to look at the IUPAC naming, and we are now looking at the IUPAC naming of alkynes. And I will encourage you to grab hold of the previous videos, especially the last video where I looked at the IUPAC naming of alkenes. Of course, the previous was the IUPAC naming of alkanes. Now you guys, I keep on encouraging you to subscribe so that you can be notified every time I'm posting a new video. If you're not subscribed, unfortunately, you are not going to get these lessons as they are coming, and it's actually something that will disadvantage you as you continue with your studies. Now, also, just before I begin this lesson, remember, share this channel to your friends and colleagues so that they can also benefit. Now, let's look at the IUPAC naming of alkynes. And when we look at the IUPAC naming of alkynes, nothing new. We are still maintaining the same rule. The first part is to identify the functional group, and in this case you can see that triple bond, carbon, triple bond, carbon, triple bond, carbon, triple bond, carbon is the functional group. Then it makes it imperative or important that you use that as part of your carbon chains. What am I trying to say? I'm saying if you want to number your carbons, you have to include the triple bond. You go all the way, so you have an option when you come here. It's either you go straight, but straight has got one carbon. If I go up, there are more carbons. Do you see that? So there's extra 2 carbons, so which means this is not the way. Even I can't go down here because there are more carbons that are following. So you can see that my line of movement, or the longest carbon chain, the parent chain, is moving all the way and then going up. This is a straight line. I'm not breaking any line. Then it means this is a what? A branch, and it also means this is a branch. You see that? So if I can now draw the structure, as I keep on saying, you can draw the structure as what is it called? As a condensed structural formula. You can draw it like this to say I've got CH3. Let me use a different pen. It's CH3, and then I go down, I've got CH2, and then going down I've got C, and then this side I've got CH3, and then this side I've got CH, and then I've got C, double bond C, and then I've got CH3. I'm going to verify everything, and then in this one I've got CH3. I think this is, if I can reduce this, I think this is what I'm having. Just check with me. As I said, it's carbon here, it's carbon 1, carbon 2. That's the best way of numbering it. Carbon 3. Remember, you need to number with the triple bond having the least number of carbons. So I'm numbering it in this direction. So it's 1, 2, 3, 4, 5, 6, 7. So even here it will be 1, 2, 3, 4, 5, 6, 7. And you know 7 is what? 7 means it's the structure of 7 means it's heptane. But now I just want to show you what you can do. You can actually draw the structure like this. I can take 7 like this, CH3, CH2. Actually I see, okay, I'll correct that. There is a problem with that carbon there. I'm going to correct that. It's missing a hydrogen. So it's CH3, CH2, CH, you see, and then CH3, CH2, CH, and then on the next one I also have CH, and then C triple bond C CH3. I made single bond, double bond there also, but let me correct this. There is a triple bond here, and in here there is H. If you check also from the diagram there. Now it's, let me make it, this is carbon 7, carbon 6, carbon 5, carbon 4, carbon 3, carbon 2, carbon 1. See what I'm talking about there? To say you can do it like this. And then in carbon number 5, I've got a CH3, and in carbon number 4, I've got another CH3. You can redraw the structure just like this, whereby you take this one, you bring it along the line, and then you take this one, you can bring it somewhere here. This one I just took it to the top, you know. But what I'm trying to say is the fact that it is moving like this, you can actually make it straight like that. It's still allowed. That's what I'm trying to say. So if I can now use this to name this compound, it doesn't matter whether I'm using number 2 or number 1. It doesn't, let me use number 1 for interest sake. It's in carbon number 2. You see this carbon number 2? There is a what? There is triple bond, and you said it's 7, so it's carbon number 2. That's where I have got, remember 7 is heptine. It's more like I'm saying 2 heptine, but I told you you can avoid this 2 here, and you can write it as hept, and then you've got 2 wine. It's heptine. So you can actually take out this 2 here, you can see heptine. You see that it's heptine. Then if you replace the 2, it's hept2 wine. Alright, then let's come back to the branches. You can see that I have got an alkyl, a methyl here. It's an alkyl methyl group, and then also I've got in carbon number 3 as well as a methyl group in carbon number 4. So here what will I have? I will have 4 comma 5 hyphen, because there are 2, it's dimethyl heptwine. See that? That is the one. And then move on to the other question here. Let's look at this question. It says, it's a bit larger, let me make it small. I hope you're able to understand what I was doing there. Now let's look at this question here. It says I need to draw the structure of 2-methyl hex 1 wine and 2-methyl hex 2 wine, and discuss these 2 types of isomers. So let's start with the first one. Let's try to divide like this. I'm supposed to draw the structure of 2-methyl. Let me draw that 2-methyl hex 1 wine. Hexane is 6, so it's 1, 2, 3, 4, 5, 6. So hex 1. So here I've got triple bond in carbon number 1. Right? What about this one? 2-methyl hex 2 wine. It's 1, 2, 3, 4, 5, 6. So they're saying in carbon number 2. So I've got a triple bond. You see the parent or the root is like that. Then you can now add the rest after. So you're saying in carbon number 2. So the first one is carbon 1, 2, 3, 4, 5, 6. So in carbon number 2 here, there is a what? A methyl, which is C, H, H, and H, right? And then 2-methyl hex 1 wine. So here, if I can just remove this numbering here, I've got a hydrogen here. Remember, maintain how many bonds? You need to maintain 4 bonds. So here I think there is a problem here. Let's look at this one. Okay, this one can do, which is hydrogen, but in here it shows that I cannot have a structure of 2-methyl hex 1 wine. Why? Because look at this, I can't have that. So I think when I was writing this question, somehow there is an error here, because look at this, is 2-methyl hex 1 wine. So the methyl can't be in carbon number 2, because at that moment I'll have 1 bond, 2 bond, 3 bond, 4 bond, then this becomes the 5th bond. What about the other one? Let me try the other one. Is again is 2-methyl hex 2 wine. So this is 1, 2, 3, 4. This carbon also cannot have a methyl group here. You see, because why? This cannot be possible, because it will have 1, 2, 3, 4 bonds. So this structure, unfortunately, this question was an error question. It cannot be correct. All right, so just discard that. Now in this question, actually in the next lesson, it has to be in the next lesson now, I'm going to look at the IUPAC naming of what? Of haloalkanes. So I was looking at the IUPAC naming of alkynes, which was just a small topic, just to say it follows the normal rules of alkenes, of alkanes. And then the now most important one is the IUPAC naming of haloalkanes. I would like you to join me in the next lesson, as it is very, very important lesson. We've come to the end of our lesson. Thank you.